Once again, welcome back to my channel Easy and Inspire. In today's session, we are going to discuss about flip-flops. Previously, we have seen what is a latch and types of latches like SR and D latch. So, before going to the topic flip-flops, let us see what is the basic difference between latch and flip-flop. So, latch and flip-flop, these two are memory elements. Both are memory elements. So, these two are used to store 1-bit data. Listen carefully. Latch and flip-flop are used to store 1-bit data. So, that is the common point between latch and flip-flop. Here I have mentioned some basic differences. So, latch do not contain a clock pulse. Flip-flop contains a clock pulse. That is the first and basic difference. So flip-flop contains a clock pulse. There is no clock pulse in latch. And so here it is clock. So it is called as synchronous device. No clock. So it is called as asynchronous device. So we know that latches are transparent devices. So in D latch we have seen that topic. So D latch is also called as transparent latch. So in flip-flop, so there is a triggering like low to high and high to low. So we will see that later. And latches are called as level sensitive, either high level or low level. Flip-flops are edge sensitive, either positive going edge or negative going edge. We have already discussed about level sensitive or level triggering in introduction of latches. So level sensitive means nothing but either high level or low level signal. So latch is going to be active only when high level is given as input or low level is given as input based on what type of requirement we have mentioned previously. So here flip-flops are edge sensitive, either positive going edge or negative going edge. I will discuss in next slides. Okay. So latches are simpler to design compared to flip-flops because there is no clock pulse here. So flip-flops are somewhat complex when compared to latches because there is a clock pulse and it must be carefully routed to the circuit. Next one. So the power requirement is very less compared to flip-flop. And last but not least, so latches are faster than flip-flops. Here it is flip-flop. We know that basically flip-flop and latch, these two are memory elements or storage elements. So in computers and calculators, we use flip-flops to store the data. So as a memory unit. Okay. Flip-flop is used to store 1-bit data. Observe carefully. It is used to store 1-bit data. So we are using a combination of flip-flops, a group of flip-flops to produce some amount of memory. So we are using combination of flip-flops. Next, we have already known latches are basic building blocks of flip-flops because if we add a clock pulse to latch, then it becomes flip-flop. So latches are basic building blocks of flip-flops. Here I am mentioning flip-flops are basic building blocks of any electronic device because any electronic device wants a memory element. So flip-flops are basic building blocks of electronic devices. So here two words flip and flop. So I'll explain these two words. So flip-flops are having two stable states. First one is logic 1, that is nothing but high. Second one is logic 0, that is nothing but low. Two stable states, either high or low. So that is nothing but bistable devices. Flip-flops are bistable devices. Okay, the term flip is used to represent one state. Flop is used to represent second state, the other state. So flip is used to represent one state. Flop is used to represent another state. So this state change occurs. Observe, the state change, one state to other state occurs depending on clock signal. Here the clock signal is nothing but control signal. So how the states are going to be changed? So the state change depends on clock signal. So observe here, we have already mentioned flip-flops are edge-triggered devices. So here I am mentioning edge-triggered. So this is positive edge-triggered because so it is 0, it is 1. We know it is 0, it is 1. So 0 to 1, it is going like 0 to 1. So it is positive going edge. If you observe here, so high to low. Observe, this is high, this is low. So high to low it is going. So it is called as negative edge triggering. This is called as positive edge because low to high. It is high to low. So negative edge. Two type of triggering. Triggering is nothing but activating this circuit. So this is the circuit. So this circuit is activated only when positive triggering is applied to the clock pulse. This circuit becomes active only when negative triggering is given. So how we are going to take positive or negative? It is mentioned in your question. So this is positive edge triggering. This is negative edge triggering. Simple to remember, low to high. It is high to low. So based on their operations, flip-flops are divided into four types. RS flip-flop similar to RS latch. D flip-flop similar to D latch. So JK flip-flop and T flip-flop. Four flip-flops. I'll discuss these four flip-flops in next video. Okay. In next video, I'll going to discuss about RS flip-flop. Thank you.